Hello, this is video number 8 on my single variable calculus 2. In this video, we're going to talk about inverse functions. Recall that a function f is called one-to-one if it does not take the same value twice. What does that mean? It means if a and b are not the same, then f of a and f of b are also not the same. The inverse of a one-to-one function is denoted by f inverse, and that is the function that undoes f. In other words, we have f inverse of x equals y precisely when f of y equals x. So if f takes y to x, then f inverse takes x to y. Let's look at a few examples for inverse function. If you look at the function f of x equals x squared, this is not a one-to-one function. The reason is we have different values, input values, that give us the same output. For example, if you look at 1 and -1, they both give us the same value of 1. So f of 1 and f of -1 are both 1. But 1 and -1 are different. So this is not a one-to-one function. However, we can fix this issue by restricting the domain to only positive numbers or non-negative numbers. And that means the inverse would be square root of x, because if we write down f inverse of x equals y, then we get f of y equals x. And from here, we can say y squared equals x, and because we know that the domain is greater than or equal to 0, that tells us that y is root x. And that means f inverse of x is equal to root x. So that's the inverse of x squared if we assume that the domain is non-negative real numbers. For part B, if you look at the function x cubed, that is a one-to-one function over the entire real line. So if we let g inverse of x to be y, that would mean g of y is equal to x, which would mean y cubed is equal to x. And from here we can get that y is cube root of x. Because the exponent here is odd, not even, we don't need plus minus. So that means g minus x, g inverse of x is equal to cube root of x. So that's the inverse of that function. If we look at the function x cubed plus 3x, that's a strictly increasing function. So because if you take the derivative of this function, we would get 3x squared plus 3, and this derivative is positive, which means h is strictly increasing. So if we have a function that is strictly increasing, then that means it is just going up. And that tells us that this function can never go back to itself. So that tells us that h is in fact one-to-one. So how do we find the inverse of this function? Let's say h inverse of x is equal to y. So that tells us that h of y equals x. H of y is y cubed plus 3y equals x. So we need to solve this cubic for y, but solving cubics isn't really easy. So what that means is we can't really find a formula for the inverse of this function. But sometimes we want to know what is the rate of change of the inverse of a function without really being able to evaluate that. So how do we go about doing that? So let me kind of summarize the two facts that we briefly talked about, and then we will do some examples. First, a function is one-to-one precisely when its graph passes the horizontal line test. In other words, there is no horizontal line that crosses the graph of the function more than once. And the second one is if you have any strictly increasing, so if you have a strictly increasing function, it would always be one-to-one, therefore it has an inverse. And if you have a strictly decreasing function, that also is one-to-one, it has an inverse. So let's look at a couple of examples on this. Consider this function, find the largest interval containing x equals 2 for which this function has an inverse. So in order for the function to have an inverse, we're going to determine when this function is strictly increasing and when it is strictly decreasing. So we're going to take the derivative. Derivative is 3x squared minus 2. We find the critical point, so we get x squared equals 2/3. So that gives us x equals plus or minus root 2 over 3. Next, we're going to look at the sign chart. So we have x, negative root 2 over 3, positive root 2 over 3, and then we have f prime of x, that is 0 here and here. Now f prime at, let's say, x equals 0 is negative, so this is negative. When x is large negative, let's say x is negative 1, let's say x is negative 10, that becomes 300 minus 2, so that's positive. And if x is positive 10, it's the same thing, so it is positive. And then the number that they gave us was x equals 2. So x equals 2 is here. So that means the interval is going to be from root 2 over 3 to infinity. So that's the answer to the problem. Because over this interval, the function is increasing. If we go a little bit below root 2 over 3, the function becomes decreasing. So the function f is increasing, decreasing, and increasing. In order to make sure that the function is one-to-one, we can start from root 2 over 3 and go to infinity. The next part is asking us to find f inverse of negative 1. So let's say f inverse of negative 1 is equal to x. We can use f to relate these two by saying that f of x is equal to negative 1. We have x cubed minus 2x equals negative 1, because that's what they gave us as f. Now we can't really solve cubics, so we'll have to basically guess what the answer is. So inspection tells us that x equals 1 is a solution, and make sure this x equals 1 is in fact in this interval, which it is. So that means f inverse of negative 1 is in fact 1. The last part of the problem is asking us to find the derivative of f inverse at negative 1. So let's say that f inverse of x is equal to 1. We're going to use implicit differentiation to find the derivative of this y. So first we're going to write it down in terms of f. Then we are taking the derivative of both sides, and we get f prime of y prime equals 1. And that tells us that y prime is equal to 1 over f prime of y. Now, what is f prime of y? F prime of y is 3y squared minus 2, because f prime of x is 3x squared minus 2. So this would be 3y squared minus 2. And then we'll have to write it down in terms of the values that they gave us. We got that x equals negative 1, because if you look at the problem, they're asking us to find derivative of f inverse at negative 1. If x is negative 1, y would be 1, because f inverse of negative 1 is in fact 1. So that means f inverse prime at negative 1 is 1 over 3 times 1 squared minus 2, which is 1 over 3 minus 2. So the answer is in fact 1. So f inverse prime of negative 1 is in fact 1. So we can find the derivative of f inverse by using this formula. Let me explain why this formula works. Let's say f inverse of x is equal to y. We will take this and rewrite it in terms of f. We get f of y equals x. Then we're going to take the derivative of both sides. We get f prime of y equals or times y prime. This is again the idea of implicit differentiation. On the right we have 1. So we get y prime is equal to 1 over f prime of y. Now all we're going to do is to replace y by f inverse of x. So the derivative of f inverse at x is 1 over f prime of f inverse of x. And that is the formula that I have put in the box. So this is a really important formula. Let's apply that in this situation. Consider the function f of x equals, they define it by an integral, and they're asking us to find the largest interval containing negative 1 in which f has an inverse. So let's first take the derivative of f. Derivative of f by fundamental theorem of calculus is cube root of x cubed minus 4. By the fundamental theorem of calculus, we find the critical points of this. X cubed equals 4 gives us x equals cube root of 4. So if we look at the sign chart, we get x cube root of 4. f prime of x, well, it's 0 here. If x is 0, which is less than this, it's negative. And if x is, let's say, 10, it would be positive. So in fact, we have to figure out where the number -1 is. -1 is on this side. So the interval is -infinity to cube root of 4. So that's the first part of the problem. Let f inverse be this inverse, find f inverse of 0. So f inverse of 0 equals x. So that means f of x equals 0. Let's write down what f of x is. F of x is integral from 1 to x cube root of t cubed minus 4 dt. So this integral is 0. We know that every integral from a number to itself is 0. So that tells us that x is 1. Now notice that 1 is in fact in this range. 1 is less than cube root of 4. So that's nice. So that means f inverse of 0 is in fact 1. So now what's the derivative of f inverse at 0? Well, that's 1 over f prime of f inverse of 0. That's the formula that we talked about earlier. So that's 1 over f prime of f inverse of 0. We saw that f inverse of 0 is 1. So that's 1. That's 1 over f prime is cube root of x cubed minus 4. So that's cube root of 1 minus 4, which is 1 over cube root of -3. So the answer is then f inverse prime of 0 is 1 over cube root of -3. You can put the negative sign on top or keep it at the bottom. It doesn't really matter all that much. You can also rationalize the denominator, but it's really not that important. To summarize, to find the largest interval containing x equals a for which the function has an inverse, find f prime, draw the sign chart, and make sure that the point x equals a is in the appropriate interval. To find the derivative of f inverse, first find f inverse of a, then by solving f of b equals a, then find the derivative of f at x, and then plug in b in there, plug in f inverse of a, and then take the reciprocal of that. So the answer to the derivative of f inverse at a is 1 over f prime of f inverse of a. And that brings me to the end of this video. So I will see you in the next video.